All right, we're going to go over this Unit 3 through 5 review, and this really is going to be what we will use for the semester test review. So here we go. All right, so we've got this, number one, we've got these two data sets. Remember the different qualities of them. It looks like this one has the median. Data set 1's median is the same as data set 2. So here's our true and falses. Okay, I don't want to go through every piece of or every answer on here. The range of data set 1 is equal to the range of data set 2. They have the same min and max. If there were outliers, they would count in that range, but there's not. The IQR of data set 1 is from 30 to 45, that's 15. The IQR of data set 2 is 35 to 50. They're both, oh, look at there, both IQRs of 15. C, the median of data set 1 is less than the median of data set 2. True. And D, data set 1 and data set 2 have the same number of data points. No, 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 no. We do not know how many pieces of data are in those data sets. E, about 75% of the values in data set 2, that's this top 75%, are greater than or equal to about 50% of the values. So this lower 50% of the values in data set 1. True. That is true. All right. So this one's very interesting because if you added up all of these percents, see, that's almost 70, and then that one's 55. So right there, just in those two frequency bars right there, we are already over 100%. So based on that, I can tell that some owners let their pets ride in more than one place. All right, how about this? Majority of owners allow their pets to ride in the front passenger seat. So the majority is more than 50%, and that's almost 70%. So I would say that's a definite majority. C, the most common place for dogs is in the back seat. The most common place would have the highest bar, and it is. So that's true statement. D, the vertical scale of the graph exaggerates the difference between the percentage who let their dogs ride in the driver's lap versus the passenger's lap. Okay, so let me look at those real quick. Here was the driver's lap, and here was the passenger's lap. Now, this driver's lap looks like about a fourth of the passenger's lap. But in actuality, it's only a half. So do you see how this scale like starts at 20 instead of, say, starting at 10, 0 and then going to 10 and 20 and then 30 and so on and so forth? So driver's lap looks like 1/4 of the passengers when it's really 1/2. So that is exaggerating the difference between the percent of drivers in the dog's lap versus passenger lap. So that's true. How about this data? Can it be in a pie chart? No, because it totals up to over 100%. So that cannot be in a pie chart. All right. Next. Here we go. We're going to have to then compute our fences. So I used the 1.5 IQR rule. So I went ahead and there's 12 pieces of data. So here is where the median is, Q1 and Q3. So there I stated them, Q1 and Q3. There's the IQR. So I did my fences. The lower fence is at -3, and there is no data below the lower fence. My upper fence is right here at 13, and 14 is a piece of data above the upper fence. Data above the upper fence or below the lower fence. So here we have a transformation of going from Fahrenheit to degrees Celsius. So here we have that the mean is affected by multiplying by 1.8 plus adding 32. Standard deviation, however, is only affected by multiplying by 1.8. No plus 32 for the spread. All right, number 5. Okay, so this is an interesting one. So I had to take, our 100 pieces of data. It said that we have 100 adult men, and so then we split them in half. Okay, so we found where that median was and where the middle, and so here it is. Now, that's, splitting it 50-50. So now I want to take this bottom set of data and find out where like the 25th piece of data is, because it's the bottom, the quartile. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. And so then that 25th piece of data is going to be in that Q, that 66, that Q1. So 66 is that Q1. I'm going to do the same thing here. I'm going to subtract down from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 5 is 14, 20. And then so this goes from 20 and then here into this one makes 28. But so that 25th piece of data is located there in that bar 8 from 71. 71 minus 66 is the IQR. All right. Which one has the smallest standard deviation, most closely clustered around the center? That's going to be D, because see how this data has the smallest range. It's most closely clustered together. Okay, smallest range, mostly close. Okay, now E is one I kind of was tempted to say that it is. But E actually has quite a bit bigger range. It's going from 1 to 10. This one's just going from 6 to 10. So definitely this one here has that smallest standard deviation. All right, number 7. Here we go. That relationship between mean and median. It is skewed to the right. Plus, you can calculate the fence. The upper fence is at 9.5, so I drew it in there. And so I can tell there are 2 upper outliers. So then that makes the median is less than the mean, and the distribution has 2 outliers. Okay? All right, number 8. So they're telling us to use the standard deviation rule to find the outliers. So the lower fence is the mean minus 2 standard deviations at 95.18. And let's see, the minimum is not below the lower fence, so no lower outliers. The upper fence is at 164. Ooh, and that max is above the upper fence. So we do have at least one upper outlier. Okay, now we have our true falses about this box plot here. IQR is about 7 from 10 to, or 80 to 87. That's true. Okay, the 75% of the students scored at least an 82. And so that's this up. And that's not true. That's 50%. 50%. So nearly half of the students scored an 82 or lower. And so, yes, that's true because that's the median. Half scored that or lower. D, 1 out of every 4 got an A. So I'm going to say no because the entire quartile is 1 out of 4 got 87 or higher, but not 90 or higher. So if that's an A. Okay. And F, the range is 26. Yes, that range includes from 94 all the way down to 68. It includes the outliers. And then here's your number 10, comparing those pieces of data. I actually think this was the same as like number 1, except for I think I added question F. About 50% of all the values in data set 1 are less than or equal to the bottom 25% in data set 2. So let's see, 50% of 1. Yep. See this? 50% of 1, all of that down there. And then the 25th percentile in data set 2. All right, here we go. We've got this skewed to the right, so I can tell the mean is going to be greater than the median. Yep, it's skewed to the right. Now, where does it look centered? At 8 or 4.5? So let's see. Does it look centered at 8 or 4.5? I think 4.5 is definitely considered a better fit for the center. All right, now population versus sample. So if you remember, okay, the population has a standard deviation of 0. If the population is, all of the cats out in the barn, and they all have the same weight, I don't know, they all have the same weight, then that standard deviation is going to be 0 because all of their weights are the same. And that means the average is whatever their weight is. And they have the same, all of them have 0 distance from the mean because they all are the mean. Okay? And then here we just were asking the questions about where the largest median is. So this one with the business leaders is, but that's not an option. So the next biggest median is this one here with the scientists. What's the value of the smallest IQR? Okay, smallest IQR is going to be this business leaders as well, from 70 to about 82. So that's about 12. And then here we have computing the fence again. In fact, I think this one was in that previous lesson. We saw that already being computed. So the fences, that puts the 14 above the upper fence. Variance is the standard deviation squared. Variance is the standard deviation squared. All right. Oh, yikesies. I should not have had this problem in there because I forgot that I hadn't taught you how to do that. So we'll just skip that one. We're going to put that into our data, calculate the one variable statistics. X bar is the mean, and then here is the standard deviation. Okay, so forget that one. All right, here we go. What percentage of the students, that's your denominator, so out of all of them, out of 690 total, what proportion of them are taking math? So the math is the 400 out of the 690. What percentage of the students, so all the students, the 690 is your denominator, are juniors taking a foreign language? So the juniors taking a foreign language is that 35 right there. That's your juniors taking a foreign language. Okay, next. We've got, what percent of those taking English? So that's our denominator, is the English takers. Let's see, that's out of the 170 taking English, who is a senior? So of the 170 taken English, 30 out of the 170 are seniors. Is that right? What happened there? What percent of those taking English? Oh, poo. Sophomores, 30 are sophomores. 80 is seniors. Okay, so that makes more sense. 80 out of 170. Okie dokie, here's this number 21, which is false. The mean is more sensitive to extremes than the median. Okay, so that is true because the mean is affected by outliers. Remember, being resistant, the median is resistant to outliers. Skewed distributions use median and IQR. If you have skew, then you must choose to use median and IQR. The sample standard deviation is a measure of spread around the sample mean. Yep. On average, how far is everything from the sample mean? The sample standard deviation is a measure of central tendency. That's saying like where the center is located. And that's not true. Standard deviation is a measure of spread. If the distribution is symmetric, then the mean and standard deviation are acceptable measures. Yes, symmetry, use standard deviation and mean. All right, the term test scores of 15 students is recorded. After calculating the mean, median, and mode, an error was discovered. One of the 15s, so that was a median score. So one of these 15s is a 17. So I showed crossing that out and making it a 17. The measure of central tendency, which will change. So the mode was 15 and now it's 17. So that changes. The median stays the same. The mean will be a little bit higher because you were having 17 totals instead of a low one down here. So that average is going to be on the higher side. All right. And 25. We have 6 scores. The median is 21. If the highest score is increased by 3 points. So here we have the highest score increased by 3 points. So that'll change the range. It will not change the standard deviation. It won't change the median because it's the same piece of data. It's just out there further. So it just might be qualified as a outlier. Okay. All right. Next, we've got 26. What is sensitive to extreme outliers? So which one's affected by the outliers? Mean and standard deviation. So mean is the answer there. Consider this box plot of sets of scores. So I can tell it's skewed to the left. So because of that, I know my mean will be less than the median. On which side of the median is the mean? The mean is less than 32. All right, and that is your review. Good luck to you on your semester test of this fall semester for statistics.